Okay, we're going to begin with the examples from this lesson. All the work done prior to it is pretty self-explanatory, so I would suggest that you just take a look over the sheets. It's pretty much just a bunch of plotting points, looking at the graphs, and just seeing what the parameters do to the exponential function. So now we're going to put everything together. We're looking at a function over here, -2 times, and there's again a multiplication assumed to be right here in the middle, 3 to the exponent x plus 8. So the first thing we do is identify our asymptote, which is always going to be that last number, the d value, and it's going to be y equals 8. And it says graph it. So that's a very important piece of information in our graph. I'm going to identify it with a red line. So my asymptote is going to be up here. And just to emphasize that, I'll put a broken or a dashed line in black. And there it is. Next, we're going to start off with our table of values. And the table of values is for the base graph. The base graph being y equals 3 to the exponent x. Now, as far as the x values go, you can choose anything you want, but I always try to choose points that are around 0. So I'm going to choose, in this case, -1, 0, and 1. And if I substitute these values into the equation y equals 3 to the exponent x, I'm going to get I'm going to choose the y values now based on these x value choices. So I have 0.3, I have 1, and I have a 3. So step number 1, I want to multiply the y values by a. So in this case, my a value is -2. So if a is equal to -2, I'm going to multiply each of the y values by -2. X's stay the same, and now the y values become -0.6, -2, and then -6. Finally, I add d to the y values, and in this case it's +8. So I still have the same x values. And for the y values, I'm going to obtain, again, these are rounded values, 7.4, 6, and 2. So what does this look like on our graph? So -1, 7.4 is going to be roughly here. When I have 0, I have 6. And when I have 1, I'm going to have +2. So my graph, in this case, is going to look like this. Let me just zoom in. Again, putting arrows on the end indicates that it goes infinite in each direction. And now I can input some properties of this graph. The y-intercept, well, it's that point where x equals 0. So that's 6. The asymptote, well, we already mentioned that, is 8. The range for all of these functions is always going to be all real numbers. The domain, however, is going to change. Oh, I made a mistake there. The other way around. The range is going to be different. Okay. The range is going to be all real numbers. But in this case, notice that the whole graph is below the line y equals 8. So in my range, I have to put the restriction y is less than 8. The domain stays the same, never changes, and the function in this case is decreasing, because as you read the points from left to right, you notice that the function starts going down. So it's a decreasing function. So I can either put an arrow pointing down for decreasing or say decreasing. Transformations, I've listed them there for you, and there you have your final graph with the steps included. For our second example, looking at same type of function, the only difference is that my base here is a reciprocal. So instead of 3, I have a 1 over 3. First things first, I have to identify my asymptote, which is the last number. It'll be y equals 7, or actually negative 7, and I'm going to graph that. So taking a red highlighter, I'm going to find negative 7 and draw a horizontal line through that value. And again, to emphasize it, I'll just go over it with a broken black line. There you have our asymptote. Next, in terms of the values, again, like I said before, I always like to pick values around 0. So I'll pick negative 1, 0, and 1, very simple, and I will evaluate, and I'm looking at the function in this case, 1 over 3 to the exponent x. So for each x value, I get a corresponding y value, and the first one is going to be 3, and then 1, and then 0.3. My a value in this case is 2, so a equals 2. So each y value gets multiplied by 2 to give me 6, 2, and 0.6. These numbers stay the same. And then I shift everything down by negative 7. Still have negative 1, 0, 1, but now I get negative 1, negative 5, and negative 6.4. So what does my graph look like? Well, at negative 1, I have negative 1, so I'm going to be over here. At 0, I'm going to be at negative 5, which is over here. And at 1, I'm going to be at negative 6.4, which, just eyeballing it, is going to be roughly here. So my graph, based on these 3 points, I know is going to go something like this. I'm not concerned about specific points when it comes to exponential functions, but more about the general behavior of the graph, the asymptote, and the only point perhaps you really want to emphasize is the y-intercept. Let's list the properties now. So the y-intercept from the graph is negative 5. We know this to be negative 7. My range, which is going to be different from the previous question, is everything above negative 7. And my domain is going to be all real numbers. Is this an increasing or decreasing function? Well, if you read it from left to right, the function is going down, so it is a decreasing function. Or it's going down. And finally, the transformation. So in this case, we have two transformations. We have vertical stretch by a factor of 2. So let me write that in. So we have a vertical stretch by a factor of 2, and we also have a vertical shift down 7 units. And there you have it. So I think you're in good form right now to get started on the homework.